Hi, I'm N. Daniel Anthony. My project title is Byzantine attacks in large wireless sensor networks. Aim: the mainstay of this project is to propose a distributed detection technique that explores reliable data fusion in mobile access wireless sensor networks under Byzantine attacks. Synopsis: in the project, first by exploiting the linear relationship between the scheme parameters and the network size. Second, for better flexibility and scalability, we derive a near optimal closed form solution based on the central limit theorem. Third, subjecting to a misdetection constraint, we prove that the false alarm rate of Q out of PM diminishes exponentially as the network size increases, even if the percentage of malicious nodes remains fixed. Existing system. A serious threat to wireless sensor networks is the Byzantine attacks, where the adversary has full control over some of the authenticated nodes and can perform arbitrary behavior to disrupt the system. Proposed system. In the project, we consider reliable data fusion in wireless sensor networks with mobile access points under both static and dynamic Byzantine attacks. Static attack. The malicious node sends opposite data with an arbitrary probability that is fixed. Dynamic attack. The malicious node changes after each attacking block, which is composed of one or more sensing periods. The module description of the project. We have three modules in this project, namely network formation, route founding, data transfer. Network formation. The network is composed of an n power limited sensor nodes and a powerful mobile access point. We assume that the nodes are randomly and uniformly distributed over the network. Route finding. The sensor network performs distributed detection. Each sensor node detects the presence of the target object by applying an application-dependent detection algorithm, such as energy detection, and sends it 1-bit hard decision report to the mobile access point. This hard decision model is adapted here for two reasons, namely 1. to reduce the transmission and processing burden of the sensor network, and 2. to enable more traceable analysis of the effect of the network size on the reliability of the distributed detection under Byzantine attacks. Data transfer. Sensor nodes want to send the monitoring data to mobile access point, where the shortest path of the network. Software requirements. Windows operating system XP and above, JDK 1.6, NetBeans 6.9 with JavaFX. Hardware requirements. Hard disk 40 GB and above, RAM 512 MB and above, processor Pentium 4 and above. The architecture diagram of a project. We have collection of sensor nodes, namely sensor 1, sensor 2 up to sensor n. It will be moved to the sensor head, and sensor head will undertake the mobile access point with the database connectivity. Contents of table after concluding the malicious node. Intimation about the malicious node to all nodes except to malicious. It has trusted authority. It will edit all the nodes. Activity diagram of the project. The data will be monitoring, will find path for training phases, and it will send data. Whether it has attack, it will receive data directly. If it has no attack, it will take alternative path to receive data. The class diagram of the project. It has node to move to the hello receiver. It has map socket followed by the map. After that, the map will receive the node and short rect to the map and will be followed to the node. Collaboration diagram. The sender will find path and will be moved to the training phases to send data to the header, and header will send acknowledgement to the sender as well as forwarding the nodes to the map. Data flow diagram. Level 0. Node will find path for mapping. Level 1. Node will also find training phases for mapping. Level 2. Node will send message to the mapper and map will send acknowledgement to the node. Sequence diagram. The sender will find path, also training paces to the sensor header, and sensor header will forward those things to the mapping, and mapping send acknowledgement to the header, and header send back the acknowledgement to the sensor header. Use case diagram. Have mobile access point as an actor and will find the selfish node direction, and the sensor will find pathing and training paces and activate node detection, and will also take alternative path and send message to the mobile access point. This is the home page of the mobile wireless sensor networks and the Byzantine attacks. It has two features: map and node. This is a mobile access point page. It's a node N483 and it has few values that you can see here: distance and the range. Node N995, it has few values and it will perform the operation. Here we will also given input values: distance as 30 and range as 5. And again node N667, it will have few values which is N995 and N672. Here also again given the distance and ranges. This is a node N672. This is considered as a result of this operation. Conclusion. In the project, both static and dynamic attack strategies were discussed. The proposed simplified pivot of fusion streams by exploiting the linear relationship between the scheme parameters and the network size. An important observation is, even if the percentage of the malicious sensor remains fixed, the alarm rate diminishes exponent with the network size. This is considered as false. This implies that for a fixed percentage of malicious nodes, we can improve the network performance significantly by increasing the density of the nodes. Thank you.